Start the recording.
Good morning.
Good morning. Good morning. So today we having one of the session. If you guys would like to join, you can join. It's a free session. FortiGate Firewall, right? So let me give you the details. This is a Zoom link, okay? So if you want to join, let me share the Zoom link. You guys can join. It's 7 p.m. just after our class, okay? So I'll wrap up the class before 10 minutes. If you guys can join it, just the FortiGate Firewall, okay? Just for the information. Okay, so let me see if recording is on. Just okay. All right. So today we have to discuss about something is the physical interface, right? So if I'm talking about the physical interface, that means which layer I'm talking? Sagar, physical interface, which layer?
It's layer 2.
No,
First, no?
first. It's a first. Physical 1, 2, 3, 4, 5, 7. So this is the application layer. Right. This is your presentation layer, right? Session layer, right? Transport layer, network layer, data link layer, and this is the physical layer. So if I'm talking about the any kind of the IP address, right? Or router, L3 switch, they all work on the network layer, right? So this is a network layer. If I'm talking about the ports, right? What does means ports? This means the TCP and UDP ports. TCP and UDP ports like 80, 443, these all work on the transport layer, right? If I'm talking about the VLANs, right? VLAN, right? MAC address, right? And the switch, layer 2 switch, L2 switch. These all work data link layer. But when I'm talking about the cables, all type cables, it could be the copper cable, could be the fiber cable, right? And even we having the Wi-Fi wireless. That's also acting as a physical layer, but this is the wireless, right? There is no physical connectivity. So it's limited to the cable, copper and fiber. So we having a two type of the cables, which is just going to give you the connectivity, right? So if you go on the Google network cables, so you'll find a lot of cables, right? So these are the cables, right? You can see you might be this kind of cable you find in the offices where your PC is going to be connected, LAN cables we called it, right? Or also these cables acting as a WAN cable also. This could be the fiber, this is the copper one, and these are the copper. You'll find these are the copper, fiber also you could say this is the fiber, could be the fiber, right? Or I just put it here more specific fiber cable, right? So you'll see these are the fiber cable. So these are the glass based fiber cable. So only two way we having the cable connections. One is the copper, one is the fiber, right? So you just have to understand what is the physical interfaces, cables, and what is a single mode cable, multi-mode fiber, like connection, Ethernet media, right? You just have to understand. So even you go in the books, you'll find this cabling in the detail. Let me show you. Yeah, so you can see here, we go a little bit down. So see, you can find it. So if any device like looks like in your computer itself also, you'll find this kind of the port is going to be allocated. Even you can see in your laptop, you'll find this kind of port is allocated. So this port is known as the NIC port, right? Or we code as a LAN port, right? So NIC is the technical name, which is known as the network interface card, right? So this network interface card, also known as the LAN card, locally network port. So you connect the cables. Which cables? So might be you can take this cable, you can connect here one end, another end of the cable you need to connect with the your this device. So once you do such kind of a connection, right? This is going to become the communication going to become or going to make a communication between your PC to your switch, right? So these are the ports, physical ports. So every switch having a different physical ports, and all ports are going to connect with the right your computers, your servers, or might be the other network devices. But yes, these all require some kind of the physical connection port, might be the NIC card, or if the network device, they're having a dedicated port as well. So if I'm talking about the RJ45 connector, this is RJ45 connector. So this is always known as the copper port. It's always RJ45, RJ40, Cat 5, Cat 6. There's two category, Cat 5 cables or Cat 6 cables. They all are known as the copper. These are the coppers. So copper means like you can see here, these are the copper cables. So instead of fiber, if you just go and find the copper cables, so these all cables are known as the coppers. Anything you can see, these all are going to be known as the copper cable. So these all are the copper cable. So further in copper itself, we having different kind of the categorization, right? So we'll explore one by one. We can have one by one understanding. Let me see. So what is understanding? Let's explore it. So first we understand what is the physical interface and cable type will understand. Physical interface is something, any device might be your PC. If your PC, it's having the NIC card, right? NIC card. We having the LAN port. This is known as the PC physical interface, right? This is the PC physical interface. If I'm going on the switch, right? Switch having a too many ports, as I mentioned that switch is having a too many ports where I can connect multiple PCs, multiple network devices. So might be from this port, I can connect this port. So this switch physical ports, right? So these are the all switch physical ports, all switch physical ports. Okay. So these are the switch physical ports. Similarly, we having a routers. So router also having a multiple ports, but there are less number of port as compared to switch. So I can connect this switch, this router. This is your router. So this is the router physical port. You can Google it and you can find the port details, right? So these are the different devices we have. Every device is having different ports. You just go and see on the Google also if you want to see that. See if I'm going here and just type in Cisco routers. So see, this is a Cisco router. So this Cisco router having a different ports. These are the all ports. See, so all Cisco router port. If you go in the switch also having a different port. So these are the ports, many ports in the switch because switch is going to connect the lot of connections. This is the many ports available in the switch. So in nutshell, every device is having a ports, and those devices ports need to connect the network devices. It could be the PC, laptop, WLC, AP, router, switch to switch, router to router. It could be any type of the connection is going to happen. This is only possible via the, physical interface. But in our industries, we having only two media which going to connect these devices. So might be I have one PC or one switch. This is the PC, or might be one router, right? So how they are going to connect? So PC doesn't having the fiber connections. PC and switch always supported the, copper connection. Copper connection. But router switch can connect to the fiber or copper. It support both. So if my switch want to connect with the router, it can be the router, fiber, both. If this router further connect with another router, ISP, right? So it could be also, maybe the copper, maybe the fiber. It's not mandatory. So let's understand what is the copper, what is the fiber. So if I'm talking about the copper having a limitations. Copper can support the like 10 gig circuits, right? 40 gig circuit, right? It's 100 gig circuits. It's absolutely fine. It can support, and even more than that support, right? But the problem with the copper is they support less distance, right? They support less distance. That means, let's say suppose you having one PC here, right? And you having the switch here, and you want to connect, you can connect, but might be it could be 10-meter away, it could be the 5-meter away, it could be 100-meter away. But if it is more than 1,000-meter away, 500-meter away, then it is not good choice. You face, latency on it. You'll face, problem in it. So if you just go here and try to figure out copper versus fiber, right? So you'll see some kind of the differences here. So let me just show you. So copper always cheaper, right? It's cheaper, but distance you can see copper support very less distance. It's 30 feet, it's 12 mile, and even more than that, right? It go 10 Gbps, right? 100 Gbps it can be also go if you're having the latest devices, 30 Gbps, 40 Gbps. But if you talk about the fiber, they are very high speeds. Fiber travel very long, right? Fiber travel very long. Distance is very high in fiber, low in, copper. So two major factor we have basically copper versus fiber. Copper's always is a choice for the LAN, right? And it having the low cost, low speed, but low distance as well. But if you talk about the fiber is used for the long distance communication. Long distance communication. So if I am trying to establish direct communication from my ISP to US ISP, this is only possible via the fiber, right? Because it's going to carry long distance communication with very high speed communication. So if you want long distance communication, high speed communication, you use the fiber. If you want low distance communication, right? Low speed communication, then please use, copper. So low distance communication, where it could be? It could be in the LAN. And high distance communication, long distance, it could be the WAN. So that's why in practical world also, your all WAN circuits, majority of the WAN circuits, which is having the highest speed, this is the WAN circuit, they belong to the fiber. But when you talk about the LAN circuit where your switch is connected and further you having the clients connected, server connected, firewall connected, multiple device connected, they are basically LAN, and this is the copper. Okay, so I believe we understand the fiber benefits and the copper benefits, right? Now let's discuss more about these cables. At least we know the fundamental of these cables, why you use and what is the benefits, right? And where we need to use. But what are the fundamentals of these cables, right? So the fundamentals of this, and the fundamentals of this particular uh, just give me 1 minute. The fundamental of this particular things is, if I am going to in my PPT, right? So if you are talking about the coppers, so these are the all coppers cables. So UTP cable, like UTP cable is always known as the uh, untwisted, twisted pair cable, untwisted pair cables. They all are known as the like coaxial cable. These are the like uncelled twisted pair cable, cell twisted pair cable. So these are the all coppers. See, so copper cable, if you're referring, so it could be the two category. One is the twisted, right? Unsealed twisted. One is the sealed twisted. So what is meaning of the sealed and unsealed? So unsealed means there are the cables which are not covered. They are the opens. So we having such kind of the diagram. So if you find, even your home wire, you find such kind of cables which are not internally coated. You can see this cable is coated by some coating material. So this is the sealed twisted pair cable, right? And it is not coated by any coating material. So this is the unsealed twisted pair cables, right? And this is a coaxial cable. Again, it's the copper cable. It's used for the television. So if you're having the dish antenna and you want to use a TV, so this is the use for the connect, your all the antenna, which is just, going to connect to get the TV signals. So this is what TV. And these are for the your LAN connections. Might be you can use it for the, not LAN. It could be used as LAN, and even you can use with the WAN as well. But it's totally depend on the scenario where you want to use. But copper also can support the WAN. But this is the three type of the cable in the copper. This is not for the network, but these are two for the network, right? So if you try to understand, we're having a two unsealed and sealed. So if we talk about little bit more about unsealed, so this is the like common networking media. We can make the RJ45 connector with the color code, right? So unsealed, like we can protect, like how we can create the connector. So we have to just use the connector, this kind of the connector. Let me show you. Where is the book? This kind of the connector you have to use. Inside this connector, we having the same cables. What I'm showing here. Let me just go there. These cables are just inside of this connector. Just place this all cables inside of this connector, and this is going to create communication. So based on the color codes. So terminated with the RJ45 connectors. So connect, what is a connector? Connected to this upper part is a connector. This is a connector. Inside of this, the cable is there. Interconnect host with intermediary network device. Whatever network device you want to connect, you can connect it. Key characteristics, they are talking about the UTP. The outer jacket protect the copper wire from the physical damage. So what that means, the outer jacket. So this outer jacket, this is the blue color. It is just protecting from the any physical damage. Twisted pair protect the signal from interference. Why they become a twisted? So they can avoid any kind of the interference. If you're not going to twist it, there is a lot of interference is going to happen. But twisted, always avoid the interference. Color coded plastic is regional electricity isolated wire from each other. Identify. So color coding is required to just make the connector and the connectivity from the cross and the straight cable for the different networking requirement. So the protection for the upper coat is just for the damage, making sure it is not happening with the damage, right? And the twisted, that means that these are not going to make any interference, right? So this is the unsealed twisted wire cable. But if we talk about the sealed, you can say it's a well coated. Under inside of this cable, we having a twisting, but they are again sealed coated with twice, thrice sealed coated. So you can say cable again one coat, second coat, and third coat. So total 3 coats are there. So better noise protection. It's a good than unsealed, right? So noise is less, more expensive, right? Harder to install, right? Terminate on the RJ45 connector. The outer jacket protect the copper wire physical damage. You can see again the same. Brad, the foil still provide the EMI RFI protection. So this is the second, you can see here. Foil said each pair wire provide the EMI RFI protection. So these are all talking about the better interference. So in this twisted might be having an interference, but in this unsealed we having the less chance of the interference, right? So this is a twisted wire always going to be, sealed twisted wire always going to be expensive, and it is always going to give the better result in terms of the communication. So you can use either one, but it's like twisted, untwisted, both are invisible in the network, right? But you should know the differences. Coaxial cable, you can see these are the BNC connectors, N-type connector, this is what televisions. So these are also coated with a single wire is there, and they having a multiple coat. You can see this is single wire, 1 cord, 2 cord, 3 cord, and this is just going to use for the TV connection, right? These are the not something for the networking. But 3 types of copper cable. One is a twisted, one is the twisted having a 2-part sealed and unsealed, and one is a coaxial cable, right? Now moving to the next, we having the UTP cabling, right? Untwisted cabling. So they having a different category: Cat 5, Cat 3, Cat 6 cables. So Cat 6 having a more cables, more speeds. If I talking about different cables, so Cat 6 is the latest cable. You can Cat 5 also use. So Cat 5, Cat 6 always having the more usable, right? And you can see these are the connector. These are the RJ45 connector, which are going to use, inside of the cables. So they have sockets, cables. They are going to, terminate this kind of the cables. And inside of the cable, we having the untwisted pair. Like this cable is there, and we just place this cable inside of the connector, and then they make the LAN cable. Okay, and this LAN cable further going to make the color code this way. So if you having one way this side this way, so if you're having this codes, green, yellow, this kind of the pair, so you having to make the just opposite in different direction. Then only they're going to talk. Else, if you make the same color code in the both direction, they are not going to talk. So the color coding is also very important in the cabling. So you not have to get these all cabling because these are done by the physical engineers. But if you get the chance, you should know the color coding so you can just remember how the pair is going to happen. Green, orange, blue, green here. You can see orange here. This kind of this, going to be used. So these are all about the copper cable. So in summary, let me just summarize here. Copper, 3 flavors. Like copper, we having a flavor that is a twisted pair cable. And in this twisted pair cable, we having a first unsealed, right? And we having the sealed, right? 2 cables, right? And the last one is having the copper cable. So these are the all about the means the coaxial cable, not copper cable, coaxial cable. So 3 type cable we have. But when you talk with the fiber, so the fiber is very popular. Everywhere you find this fiber cabling. So fiber cable is for the long distance, right? And it is going to pass the signal inside of the fiber in form of the light, right? So in copper, signal pass in term of the electric pulse In copper, signal pass in terms of the electric pulse, but in fiber, it's always pass in terms of the lights, right? So the fiber cables, you can find even your router itself from the home, there would be a fiber cable connected. You can find it is easily from there. There might be a find one of the router is connected with the cables. That is a fiber. Also, you can go and check any of the office network, might be your office network, where you're sitting, any kind of the banking networks. So you'll find the fiber cable is terminated. Even though you walking on the road, you find some days some fiber, repair is work in progress. So you can find different even fiber media everywhere available, and it's easy to see. If you're roaming around, you can see anywhere fibers. So fiber further categorized in two parts. One is a single mode fiber, one is a multi-mode fiber. So if I'm talking about the single mode fiber, and if I'm talking about the multi-mode fiber, so what that mean? So multi-mode fiber is for the low distance. You just have to understand. If you have to use a low distance coverage, right? Use the multi-mode. If you're having the long distance coverage, use a single mode. So multi-mode and single mode, both having a different characteristics, but the core difference is a distance, right? So long distance application, and this is something up to 550 meters, half kilometer you can use, 1 kilometer you can use, but this is something within the office, within the buildings, we can use a multi-mode. But you're having the very long distance cable, then basically that is going to use by the single mode fiber. Okay. So fiber having a two flavor, one is a single mode, one is a multi-mode, and these two can be used for the communication. Now, if I am talking about a single mode communication, so what is happening? So let's suppose this is your fiber, this is your fiber cable. So if anything you're sending, it is going to straight. So your signal is coming and it is going to straight via the fiber. Single ray of line is going to be passed. Single ray of line. But same thing if you're going to do in the multi-mode, if anything is going to hit inside the fiber, they are going to create some kind of this mode. Might be this. So it keep reflecting inside of this particular fiber cable. Say the multi-mode core means inside bandwidth is big. The single mode core, that means the inside capacity is small. So very small core, larger core. Due to the larger core, you can see your signal is just going up and down. But here just one. So this is the fiber, single mode and the fiber mode. So you can see long distance application used for the expensive lasers, very small cores, larger cores, user less expensive LEDs, up to 100 GPS over the 550 meters, it can be supported. Further going to down. So you can use where enterprise network. Enterprise network means the office network, campus network, branch network, long haul network, very long internet, right? Submarine cables, that is a undersea cables. That's also all use the sea. So if you go and just search the Google sea cable, map. So submarine cables you can see. So you will find that in sea, a lot of cables are there for different countries, and these all are the fiber cables. These all are the fibers cables. See, this is how all world is connected with the sea cables. See, This is the grasshopper. Even you can see how India is connected with America. So where we are, I try to figure out. Let me show you. Germany, Poland, Brazil, Algeria. Yeah, this is the India. Okay. So see, this is the India and this is the Nepal. You can see. So Nepal doesn't having any sea. See, Nepal don't having any sea. So if Nepal want to talk to India, so Nepal traffic always go via the India or Myanmar or might be via the China because they having the sea areas, right? So if they want to go US, right? So how they can go? So where is the US? This is Australia, right? So Australia, we having see this cable, single cable is connected here between these two companies. Indigo Central. So Sydney Point, Australia, this is a one cable connected. So India having a lot of cables. You can see Bay of Bengal having the cables. This cable you can see going somewhere. I don't know where it is going. Australia, Singapore cables. So a lot of cables are there. North specific. Let me see where the US. This is the United States. Okay. So might be this United States is connected via this way somewhere. This cables is going, and this is connected with the India. See, so might be this cable. You can see this cable is coming from the India. See this cable, and this is only might be going to the US. So might be some other also cross connect we have, but you can see these all cables. These are the C cables. Trust me, these are the real C cables. And if anyone is going to cut, right, your communication is going to break. So under the sea, we having these are the all fiber cables, all fibers. Every country is connected with the sea cables. Okay, so this is how sea cable looks like. So if I'm talking again with the physical, so you can see this is the submarine cables, and these are the fiber connectors. So you can see we having a connector LC connector, Lucent connector. We having the LC connector, and we having SC subscriber connector. So subscriber connector dia is small diameters, and the your LC connector is a high diameter. So you can use somewhere LC supported, somewhere SC supported. So straight SD connectors, straight tip. This is also fiber cable. This is also supported duplex multimode LC connector. This is also supported. So it's totally depend on the SAP type and what type of the mode you are supporting. So might be the multi-mode that use the SC connector, your single mode use the SC connector, multi-mode use the LC connector, like that. So we having a different kind of the connections. All cables can be used in different scenario, but these are the four type of only connector available. In behind this connector, we having the cables, right? But connector is going to connect to network devices. This connector is going to terminate on the network devices. Okay, so you can find the fiber cable and see what all connector connected and how it looks like. You can see here. These are the patch codes. These are the again fibers, and these are the patch codes, which is like it is going to be connected. So this is all about this fiber patch code and how this. So see LC SC multi-mode patch code, SC ST SC single mode patch code. So it could be many combination. SC SC multi-mode patch code. So multi-mode something is we having the large dia, we have to reflect the light within the cables. Okay. So I believe we are good with this, right? So connection, single mode, multi-mode fibers, copper, we understand. Connections, we having Ethernet, share media, and point to point. So what is that? So if I'm talking about the connections, so what is share media, right? So share media, if I'm talking, so just think about, let me see, they have done somewhere. So, okay. So if I'm going to use the share media, right? So Ethernet, right? Shared media. Ethernet shared media is something Let's say suppose this is your switch. Switch could be multiple port. So this multiple port can be shared with the multiple VLANs, right? So multiple VLANs is going to connect to the router, right? So any communication is going to come, they will reach to the router, they further go to the internet. So this is known as a shared media. Shared means we having the multiple connections, multiple users are connecting there. But if I'm talking the point to point, so point to point, one to one talking. So this is the one P1 and this is one P2. So this could be might be the one PC and this could be the another PC. So they are just talking point to point. No other PC can be connected. But in shared media, we can connect multiple PCs together, right? So if you go here, let me just show you something. Let me show you images. You can see shared media is something your LAN cables, right? So you can see multiple computer can be connected. This is the hub, right? And point to point, one to one communication. So you can see point to point somewhere. This is the link. So this is a point to point, right? This is the point to point links. So let me show you here. So we're having a bus topology, we're having the star topology. You might be aware about that. So let me show you shared media first and then point to point. Here, let me show you. Ethernet shared media. So these are the Ethernet shared media. You can see these are just one media that is going to be shared by the, it could be the hub, it could be the repeater, it could be the switch, where multiple devices going to be connected. So whenever we having the one network, one device where multiple devices connected, then it is known as a shared media. And when I talk about Ethernet point to point, so if you talk about the Ethernet point to point, that is, see this diagram. So there is a single devices are connected in series, point to point, point to point. There's no series of devices connected to each other. See, this is the point to point network. These are all the point to point network. So one to one communication, likewise the WAN circuits, they all one to one communication. These are the point to point network. Okay. So don't be confused. Shared media, if you say some, you understand something is connected in the series of the network. Series of the network means the multiple device sharing the communication, right? And after sharing those communication, they are getting, communication over that shared media. But if I'm talking about the point to point, that means there is a one to one communication that is not going to be shared between the multiple devices. Okay. So this is something about the physical interface type, right? Now we left with the identity interface cable issues, right? What kind of the cable issue can be happen? So every router, we could find the different kind of the issues like collisions, error, mismatch of duplex, speed. So if I am going on the router, right? Let me show you. If I am going on the router, actual one, what happened? Okay. So if I'm going to open a topology, any of the router, so you will just open it. So you will see all problem, whatever the router problem having, all problem you can see any interface, you just go there, like gig 0 by 0, show interface gig 0 by 0 by 0. Just check. So you'll find a lot of information here. whatever they have mentioned here. So I'll explain in detail what those mean. But you can see collision, error, mismatch, duplex, and speed. These all information available on the interface. So you can see one by one. So let me just, so collision, you can see collisions, errors, see errors, right? What else? Mismatch, duplex. So duplex is where? See, this is duplex, right? What else? Speed. So this is your speed. So interface can have the collisions. What is the collisions? Collision something is, might be I'm sending a traffic, right? I'm sending the traffic and someone also send the traffic at the same time. So I'm sending the traffic from here and someone also send the traffic at the same time, then it's a collision. The traffic get collided, right? So in that case, there is a problem. So collision can happen because multiple devices sending the traffic at the same time. So they are going to make a collision and my traffic going to be lost. This is a collision. So collision always, if happen on the router or switches, they're going to show you there is a collision or not here, right? So this is a collision. So collision can always happen on the shared media, right? Errors, that means you having any kind of the error on the interface, right? Interface errors means you cable having error, circuit having errors. So those errors is going to be also reported. Your performance is going to be, degraded. Your performance is going to be degraded. So if error is going to happen, that means your ISP is not good, your cable is bad, some issue with your cables, some issue with your ISP circuits, device, and that's why your error is there, right? So this error is going to be happen. Duplex, that means there is a half duplex and full duplex. So let's suppose these two PC, I want to communicate, and I said the duplex here as a half, right? Here I said duplex as a full, right? So duplex mismatch. So might be this device will not come up, or might be these two switch connected, right? Each other. So we have to make the interface duplex. Here is a full. So here also will be the full, not like half. So if I make half here full, so here it is going to send 100 Mbps traffic, 1000 Mbps, it is going to receive 500 only, half. So this is like getting the problem. In half duplex, one person is only speak, another is going to listen. Once they finish they speak, another will going to speak. But in full duplex, both can speak at the same time. So in the real world, let's suppose I am running in the half duplex. So if one is sending the data, another will simply receive. He will not send the data. But if going to send the data him, then collision is going to be happen. So that's why full duplex always a good practice. Where collision is not going to happen, both can talk, right? So this is why, likewise, I am talking, you also start talking. So you're not able to understand me, what I am talking. And I am I am not going to understand what you are talking. So this is a collision is going to happen between you and me, right? So this is because of the duplex. And speed is something, what speed I want to use to make the communication. So if I have the router is connected with another router. So how many traffic I can process? 100 Mbps, 200 Mbps, 300 Mbps, whatever traffic I am going to process, that is a speed. So speed is always going to be configured on the devices. So you can see here also we having the speed, that is by default speed is 100 Mbps. You can see where it is. So see, this is a duplex and this is the speed. So if you want to configure anything on the interface as a duplex, so if you go on the interface, let me show here, configure the interface gig 0 by 0 by 0. So you can define the speed. Speed, you can define 1000 Mbps. You can give 1000, you can give 10 Mbps, right? So 10 Mbps, right? You can put the duplex. Duplex, you can put, there is two option. Auto means it will auto negotiate the from other devices. Means what that means? So let's say suppose your device having a duplex half, right? And another device I configure auto. So it will negotiate the half automatically. It's a full, so it will negotiate the full. But I define the full here, then full here also required. Here half, the half is also going to require another sides. So duplex, you can define here, right, as a half. So once I'll do that, see my parameters earlier, it was a full, see, it was the full duplex and 100,000 Mbps. But now if I'm going to check it again, the same, you'll find your speed is 10 Mbps and duplex is half. So it's changed, right? So this is how it can be done. So if you find the interface cable is used, so this cable is used means your cable having a problem, your device port having a problem. So this kind of the issue probably you are going to. So this kind of the cable you are going to, this kind of the issue you are going to get collision, error, mismatch, and speed. Okay. So you guys can join what I shared the meeting after 10 minutes. Okay. So let me share it again. So if you wish, just the coordinate session is going to be happen with another trainer. I'll be also there. Okay, for some time. So you can guys can join, and rest of the topic will cover, because this all we cover, right? Sagar, we discussed because IPv6 we already discussed. There is no problem. We discussed these things in front of you or not? These parameters, wireless, we discussed, right?
Oh,
Virtualization,
yes.
MAC address. This one, this topic,
This MAC address is done.
done, right?
Yeah.
So I believe everything is done, right?
Yes, now.
Okay, so let's connect one or two more session. I'll just summarize a little bit either whatever you guys think. Okay, so tomorrow, day after tomorrow, we'll connect, and I'll arrange the session more if required. Okay, so I'll review the syllabus. I'll put some more like effort in some other directions so you guys can understand. So almost we are done with the syllabus. There is nothing is pending from my side, but still, what I'll do, I'll just try to cover a little bit IPv6, which left in middle. So that's all. Okay. So let's connect in a next 10 minutes if you guys wish to join the coordinate firewall. Okay.
Okay.
Okay. Thank you. Thank you. Bye bye.